All right, so here we'll be installing the ball caster on the back of the robot. For this, we'll be using the provided ball caster, and for simplicity of installing it, in the case that you do have the Pi on there, I've opted to use just some M2.5 socket-headed cap screws. M2.5 by 15 are these ones, and then with their associated nuts. The kit does come with some screws that should work, but in the case that you do have the Pi mounted, you have to come in at a slight angle, and with it having that ball-ended cap screw, or ball-ended Allen key, works a lot better than trying to come in there with a little Phillips screwdriver to make it happen. So first thing to do is to remove your ball bearing from this, set those both to the side, collect your nuts and screws, remove the Pi, so all that we have is just this base piece. Now it works best to use a small pliers to pick up your nut like this when we're working with it. So we'll take our mount, put it on the back here, first drop in a First drop in the screw, try to get that right down. Good, we got it on our first try. So now we need to use a little hex key for this. This is at least in the current revision. There's a chance a future revision adds more space to allow for using of a tool like this iFixit kit. But we'll see what the space looks like and if there's requests for that. So from there, we can just push this on. Now holding that in this hand, so we have tension on the screw that's in there. We've installed this, and now you can see that we have that loose. Now with my other hand here, I'll pick up the nut. And it works best to pick it up on the end like this. Now I can push that onto there, let go of that. And now I can just start threading it in, just tightening that. So again, this takes some skill and effort to make work, but with a little bit of practice and a little bit of trial and error, you'll be able to make it happen. So now I'll repeat that process. So now I'll line up this guy. Let me zoom in here. So now I'll line that up. Right like that, so it kind of click into place. Now what I can do is take the next one, again, just drop it in. So now we've got that there, that's fallen all the way down. I set that into there. Now it's not quite. Need to adjust this down a little bit. There we go. So now that I've got that, again, holding it in the hand like that. Bring this guy, put it on there. Whoop. I'll zoom out here so I'm not so constricted by the camera. So now, holding it with my thumb, grab this, put it on there, and it works best if you can just let that fall down. And then now we're just threading that right in. And it's good to get this pretty tight, because once you put in that ball on here, it's pretty difficult to pull the ball off with the with this still mounted. You can kind of push it off, but it's best just to get it as tight as possible. Again, and also if you wanted to add some Loctite onto this guy when you're sure that you're happy with the design, that might be another good thing to do. And then you just put the ball on top like that and just pop it right in. So then there's our rear wheel. Now that we have also all of our motors on, let's look at the wheels themselves. So here's the wheel assembled. This was previously on a robot and just pulled right off. When they come in the kit, they're fully disassembled. Let me grab a Phillips here, show you what that looks like. So these are the components. So we have that piece, this piece, and then these screws. So how I usually install them if I'm just starting from scratch like that, I'll drop this piece onto the motor shaft, I'll put on this, and now note the orientation. This is slightly conical, and you want that cone to be facing towards the inside of the wheel. Additionally, on the wheel, you'll see in here how there's the, let me zoom in, how this has the countersink. It would make sense for you to put the screws into the countersink, but this has a conical shape that corresponds to the conical shape on this piece. So the right orientation is to put these two together, and that lets you get a good seat in there. Not sure about the production of these, why that's the case, but I'm just running with it. So let's see here. Let me show you guys this process. So we'll set that up. We'll make sure that we have this piece in the right orientation. Again, that's slight conical facing upward. Set that down right like that. And then we'll take this piece and just come in on top of it. So now, because you need to get some compression in there to be able to actually screw it in, if you look there, see that separation between this piece and where that, between this piece and where that screw is, we have to go around and clock it as we're screwing it into place. So I'll align this piece with the bit of metal underneath it. So I first align one of them, pushing it off to the side. And also I want it to be up on top. So now see here how this one is up on top of the screw. We'll start there. So now with these two aligned, I'll just start threading that in. And then once I start to feel a little bit of tension, now that one is in. That one's in. This looks really bad, but this is just the way that I've been doing it, and it's been working out. So now that one's in, we'll move on to the next one. We'll align that with a flathead screwdriver here, so that will push out of the way. Oops, sorry, show you that. So this started off misaligned, so we'll align that, and then that guy can be pushed over to be in alignment. So with that, I will, again using 2.5 hands here, be holding up the robot, pushing this up to make contact, and threading that in. So now we've started that one. You can see there we've started those threads, so now we'll move on to the last one. And sometimes if one of them doesn't want to go, you'll loosen up one of the other ones just to give more available flex. Push up on the bottom, push down as you're screwing in. and then just go around and torque all of them down. And again, you'll want to get these pretty tight. You don't need to strip out the Phillips head, but best to not have your wheel walking off. So that's that. And now this might be too far out when you put on the encoder mount. So like this, it might interfere. We don't have any interference issues on this one, but there's a chance you put it too far out. If that is the case, just loosen these up, push it in a little bit further, and again, go around and tighten it. Now, I already have one of these assembled, and we're going to try live a new process for installing this. A little bit risky, but we'll see how it pans out. So I've got the right insert in there, the plate on the back already screwed on. We're going to try just pushing it on. We'll see if this works. If it doesn't, then we'll go and change it around. Oh boy, there we go. Okay. So now we can go to about the same place there, about the same level of gap. Slowly pushing it down. Seems to work best if you push in the center. There we're making contact with the screws, so I want to be a little bit further out. I'll take a flat head and just slowly push. So now, there we go. We've got about that much room there, much tolerance, maybe a little bit less, but again, so when you're actually doing wheel odometry and want to know the distance from the center of your robot to your wheel, that's where this will start to come into play, the actual exact measurement there. For just doing simple driving around of the robot, this isn't super important, let's say, as we're going to have our encoder magnets just pressed fit onto here. And there's plenty of room here between that encoder magnet and where the encoder is mounted, that's not going to have any effect on your level of precision. So from there, I guess I should first have some magnets running away from me. Let me just put those back in their place. And now I'll tighten down these so that we have it locked in place. Perfect. So now for the encoders, you saw me just push that in there. So we have a encoder magnet right here. You'll get this with your AS5600 encoder. So again, this is a dipole magnet like I was mentioning earlier, and this is our encoder mount. So there's a spot on there to be able to install a set screw if you wish. I just press fit it on, and that hasn't had any issues. For long term, it might be useful to put a small set screw in there, but again, that's another piece of hardware. If you want to put it in, that should be an M2. So now with that magnet mounted on just a piece of metal, you can just push it on, slide that metal to the side, and that leaves your magnet behind. And the magnet is stuck onto the shaft, as that's a piece of magnetic steel. So another option is you can just pre-install the magnet into this, just line it up and push it on. And you see there how that magnet got pulled in a little bit. That just pulled it in to go flush with the end of the encoder, or sorry, the end of the motor shaft. So now with that, we have a robot all set up that we can move around and drive. Yeah, so the next step will be looking at wiring here of the encoder. adding wires on our battery pack, and installing the Pi and wiring to the Pi for the various electronics.